determine the region of the enclosed, or determine the region enclosed by x equals 1/2 y squared minus 3 and y equals x minus 1. All right. So the idea here is we're gonna do an integral, break this up into boxes, and we can do an integral going this way. Now the problem with that, doing delta x, would have to break it up into two parts, I think. So we'd have to break it up into this part, which is only the parabola, and this part, which would be the parabola minus the line. So a way to kind of get around that is we could actually do the integral for this, I think. We'll see, maybe, possibly, with respect to y going up. And yeah, maybe we're going to try that. We're going to see how that works. So instead of doing, when we go from left to right with delta x, we do the top function minus the bottom function. This time we're going to do, if we go in the y direction, we're going to do right minus left. So the right function minus the left function, which in this case will be the line minus the parabola. And so first thing I want to do is we want to get these intersection points, which it looks like 1, 2, negative 1, 2. Just to make sure, let's see here. This is x. I'm going to rewrite this over here as x equals y plus 1. So this, I'm going to find out where this equals that. And so let's see here. 1/2 y squared minus 3 equals x minus, no, y plus 1. Y plus 1. Math. I'm going to multiply everything by 2, just because I don't like fractions. You know, fractions are fine. I just have a disdain for them, which is probably unfair, but such is life. All right. Moving these together, y squared minus 2y plus 8 equals 0. So now we got a quadratic. Break this up. I'm going to break this up into y minus 4 times y plus 2. Because 2 times 4 is 8. And negative 4y plus 2y is negative 2y. So yes, maybe, possibly, good chance, might even be correct. So now we're going to say y is either 4 or 2. That doesn't look anything like the graph. So if x equals y plus 1, then x is going to be either negative 2. Oh, there we go. And y is either going to be x equals y plus 1, be 5, or negative 1. Is that true? Yeah, that graph is totally wrong. Okay, so I think the shape of the graph is correct, but the intersection points are wrong. So we're going to use y equals negative 2 or 4. All right, so now we got the 2 points. What I'm going to do here is, now we're going to break it up into parts. We're going to go, do it better like this. We're going to find that spot. We're going to work our way up with rectangles. And the height of each of these rectangles is going to be delta y. And so now we can take this and do an integral. So we're going to do an integral. We're going to do right minus left. Right is y plus 1. And then the left, which we're going to subtract from this here, is going to be 1/2 y squared minus 3, and I'll put a little delta y there. I'm going to integrate this from negative 2 to 4. So now, at this point, it's just going to be math. I like to write delta when I first write this up, and I'll change that delta y to a dy. The way I'm doing it is the same. It's just that a delta y is a small difference in y, where a dy is the derivative of y. It's the infinitesimally small y. For what we're doing, same idea. All right. So this is going to be, I'll distribute this negative. So I'll say negative 1/2 y squared plus y plus 4 integrated from negative 2 to 4 dy. All right, so we got that part. Seems reasonable, almost plausible. Now we're going to do some math. Negative 1/2 y cubed over 3 plus y squared over 2, just the power rule, nothing big and fancy. Negative 2 to 4. I'll rewrite this once as negative y cubed over 6 plus y squared over 2 plus 4y, negative 2 to 4. Plug in some numbers. So we have negative of, make sure the parentheses, yep. Oh yeah, because we're subtracting off that, yep. All right, I'm good with this. So we'll do negative y cubed, which is going to be 4 cubed, which is 64. 64 over 6 plus 16 over 2 plus 4 times 4, which is 16. And we're going to subtract from that negative 2. So negative 2 cubed is 8. Negative 8 is 8 over 6 plus negative 2 squared, which is 4, over 2 minus 4 times negative 2, which is negative 8. Yep, that seems reasonable. So now I'm going to distribute this negative and do some simplifying. So 64 over 6 is 32 over 3. Do I want to do 3s? Maybe I don't want to do 6s. Maybe I'll leave it as that. I'll leave it at that. So negative 64 over 6 plus 8 plus 16 minus 8 over 6 minus 2 plus 8. All right, so now get all the pluses together. 8 plus 8 is 16. 16 plus 16 is 32. 32 minus 2 is going to be 30. So we got those. Minus 64 plus 8 over 6. 64 plus 8 is 72. 72 over 6 is 12. So let's see here. 72 over 6 is the same as 36 over 3, which is 12. So this right here is 12. And so we have 30 minus 12, which gives us an answer of 18. Bam. And so our answer for this question right here of determine the area of the region bounded by 1/2 y squared minus 3 and y equals x minus 1 is going to be 18. So there's two ways we could do this, kind of back up, big idea here. We can integrate in the y direction, or we can integrate in the x direction. If we integrate in the y direction, we need to solve for y, which I did right here. If we want to integrate in the x direction, we would have to solve this for x, and then we would do the top function minus the bottom function, which would be parabola minus the line, but we'd have to break it up into two portions and worry about just the parabola over here, because that part's just the parabola, and top minus bottom doesn't really make sense. Then we'd have to be careful with the signs and square roots and that sort of thing. So just to avoid that whole mess, I decided to integrate with respect to y. So we solved everything in terms of y, did the right minus left, integrated, made sure that I used the correct endpoints because the graph is wrong, and worked through it and got an answer of 18 square units. So hope that helped. See you next time.